Welcome to W Math class. Today we will example some even function of Fourier series expansion. Find the Fourier series which represents the function f of x is equal to mod of cos x in the interval minus pi to pi. First we show that f of x, this function is even function. So f of minus x equal to f of minus of x, and this minus is absorbed by cos x, therefore this is given cos x, and as mod of cos x is equal to f of x, therefore f of x, f of minus x gives f of x, therefore f of x is an even function. F of x is an even function. We know that the Fourier series of a even function is given by, in the interval minus pi to pi, is f of x is equal to a0 by 2 plus n equal to 1 to infinity an cos of nx, where a0 equal to 2 by pi 0 to pi fx dx and n is equal to 2 by pi 0 to pi fx cos of nx dx, n equal to 1 to 3 dot dot. Here we find a0 and n in the interval 0 to pi, a0 and then n, and f of x is equal to, we put a0 here and then n here, then we get the Fourier series expansion of f of x. First we show that mod of x, we know mod of x is equal to x for x greater than 0 is equal to minus of x less than 0. Mod x gives always positive value. Where is positive is positive, negative then is positive. Here f of x is equal to, we here the limit is 0 to pi, so if we f of x takes the value cos of x for 0 less than x less than pi by 2, as all sine positive, all sine tan cos, therefore first quadrant 0 to pi by 2, 0, this is pi by 2, this is minus, this is pi, and minus of cos x in pi by 2 less than x less than pi. In the first quadrant cos is positive and the second quadrant cos is negative, therefore minus pi by 2 less than x, this equal to, now we find a naught. What is the formula of a naught? A naught is equal to 2 by pi integration 0 to pi f of x dx, and if we break down these two part, limit 2 by pi integration first 0 to 2 pi 0 to pi by 2 fx dx plus integration pi by 2 to pi fx dx, this is cos x, and pi by 2 to pi, this is minus cos x. 2 by pi integration 0 to pi by 2 cos of x dx plus pi by 2 to pi f of x minus cos of x dx. On integrating we get cos x, integrate করলে কত, sin x 0 to pi by 2 plus this 2 by pi multiplied to both, plus minus minus, this is cos of x, integrating we get sin x, pi by 2 to pi. Putting this limit we get 2 by pi sin pi by 2, this is 1, sin 0 0 minus sin pi, this is 0 minus sin pi by 2, this is 1, equal to 2 by pi 1 minus 7 is a plus 1. This is equal to 112 4 by pi. Therefore, A0 is equal to 4 by A0 is equal to 4 by pi. Now we find to find the value of an for an even function. We know that an is equal to 2 by pi integration 0 to pi f of x cos of nx dx. Therefore, an this is equal to 2 by pi integration 0 to pi f of x cos of nx dx, and we break this limit 2 by pi integration 0 to pi by 2. In this interval f of x gets the value cos x, cos of x cos of nx dx plus integration pi by 2 pi. In this interval f of x gets the value minus cos x, cos of nx dx, and 2 by pi is multiply both the term, and we know that 2 cos of a cos of b is equal to cos of a plus b plus of cos a minus b, and we apply here. If we multiply 2 here and here, then outside 1 by pi in integration 0 to pi by 2, this 2 here 2 cos x cos of nx dx, and this gives cos of 1 plus n x plus cos of 1 minus n x, and plus a minus these two here 2 cos x cos of nx gives same value here a dx here, then bracket here, and this second bracket here, and here dx minus plus a minus, and these two here 2 cos x cos of nx dx, get the term cos of 1 plus n into x plus cos of 1 minus n into x, 0 to this limit here pi by 2 to pi, here also dx, and this third bracket complete here. And if we integrate this, we get 1 by pi cos of 1 plus nx dx. This gives sine of 1 plus n x by 1 plus n, in bracket here, plus this term if integrating we get sine of 1 minus n x by 1 minus n, and limit here 0 to pi by 2, minus if we integrating this term we get cos of 1 plus nx. This gives sine of 1 plus nx by 1 plus n, plus this term we get sine of 1 minus n x by 1 minus n, and limit should be pi by 2 to pi by 2 to pi, and here this bracket complete here. And if we put this limit in earlier, we have sine of pi by 2 plus, we put this limit here first, then we get some, if we put pi by 2 upper limit here, then get sine of 1 plus n pi by 2 by 1 plus n, and this limit here the sine of 1 minus n pi by 2 by 1 minus n. And if we put lower limit 0 here, sine 0 0, there sine 0 0, and if we put here pi by 2 to pi, if we put pi here, sine pi this is 0, and this is sine pi this is 0, therefore we get 0. And lower limit pi by 2, if we put here and here, we get minus bracket sine of 1 plus n pi by 2 by 1 plus n, pi by 2 put here and then here, plus sine of 1 minus n pi by 2 by 1 minus n, and this bracket here completed. Now we know that sine of pi by 2 plus n pi, this is n pi by 2, this is cos of n pi by 2, sine of pi by 2 plus theta, cos theta, sine of n pi by 2 plus n pi, as if we multiply here sine pi by 2 sine n pi by 2, and this gives cos of n pi by 2. If we sine of pi by 2 minus theta, then also cos theta, therefore this gives 1 by pi integration sine of pi by 2 plus n pi cos n pi to 2, cos of n pi by 2 by 1 plus n, plus sine of 1 minus sine of pi by 2 minus n pi, this also cos of n pi, cos of n pi by 2 by 1 minus n. This minus and this minus gives plus, sine of pi by 2 plus n pi by 2. This gives cos of n pi by 2 by 1 plus n, and this plus a plus a plus plus a plus a plus cos of n pi by 2 by 1 minus n. Now we have cos of n pi by 2, cos of n pi by 2 by n plus 1. This gives 2 cos of n pi by 1 plus n, and if we 1 by pi 2 cos of n pi by 2 by 1 plus n, this term and this term, plus this and this gives 1 minus n 2 cos of n pi by 2. If we common 2 here and here, 2 by pi cos of n pi by 2 by, if we actually common cos of 2 cos of n pi by 2, then what come 2 cos of n pi by 2 and divided by pi 1 by 1 plus n plus 1 by 1 minus n. Therefore 2 cos of n pi by 2 by pi and 1 plus n 1 minus n, 1 plus n into 1 minus n LCM, and then 1 minus n plus 1 plus n, plus n minus n out, 1 and 2, and this 2 into 2 4, 4 cos of n pi by 2 by pi into a plus b into a minus b. This gives 1 minus n square, and this gives an. Here an, this is equal to 4 cos of n pi by 2 pi into 1 minus n square. If we put n equal to 1 here, then we get something by 1 minus 1. This is something by 0, and this gives infinity. And we know that Fourier series cannot get an infinity, so this function is for except for n equal to 1, and for n equal to 1 we get a1, and we should compute a1 and then put the value. As if we put n equal to 1, this term gives infinity, so we compute for n equal to 1, we get a1, and a1 this is equal to cos x into n equal to 1 cos x into cos x, cos square x dx, plus a minus cos x into cos x, n equal to 1 as cos square x. Therefore a1 this is equal to, we put actually this line for n equal to 1, a1 is equal to 2 by pi integration 0 to pi by 2 cos square x dx plus integration pi by 2 to pi minus cos square x dx. How come? Now we put n equal to 1 here, then a1 2 by pi 0 to pi cos x into, for n equal to 1 this is cos x, therefore cos square x dx, plus a minus plus minus cos x into cos x for n equal to 1, this gives cos square x, and we compute the value, and we cannot integrating cos square x, so we use some result. 2 by pi integration 0 to pi by 2. If we these two here multiply, then 2 cos square x, and this gives 1 plus, here we common 1 by 2. If we common 1 by 2 here, then 2 cos square x, and this gives 1 plus cos of 2x by 2. Here 2 here, this dx plus a minus pi by 2 to pi 2 cos square x. If we common 2, then 2 cos square x, and this gives 1 plus cos of 2x dx. And if we common 2 and 2 here, then these two and these two cancel, and 1 by pi, if we integrating this, we get, as we common 2 and 2 here, 1 plus cos of 2x dx. This gives x plus sine of 2x by 2, 0 to pi by 2, minus x plus sine of 2x by 2, pi by 2 to pi. And if we put this limit here, 1 by pi, if we put pi by 2 here, upper limit pi by 2, sine pi by 2, this, if we put x equal to pi by 2, pi 2 into pi by 2, the sine pi, this is equal to 0. And 0, if we put upper limit 0 here, this is 0 and this is 0, so we cannot put this limit. Minus, if we put pi by 2 here, this gives pi plus sine of pi, 2 pi by 2, this is sine pi at 0. If we put lower limit here, pi by 2, therefore pi by 2 plus, if we put pi by 2 here, 2 into pi by 2, this is sine pi is equal to 0. Actually this is a limit. If we put here, we put upper limit in this term, lower limit in this term, and if we, this bracket is complete here. 1 by pi by 2 minus pi minus a plus pi by 2. Therefore 1 by pi by 2, this gives pi minus pi, this is equal to 0. Therefore a1, this is equal to 0. So our required Fourier series is f of x is equal to a0 by 2 n equal to 1 to infinity an cos of nx. We put a0 and an here. Therefore the required Fourier series f of x, this is equal to a0 by 2. Here we compute a0. First we compute a0. Here a0 is equal to 4 by pi. Therefore a0, this is 4 by pi, so you get pi for a0 by 2 plus summation n equal to 1 to infinity an cos of nx. Here n equal to 1 to infinity. Here we compute a1, this is 0. a1 we complete, this is 0. Therefore summation n equal to this 1, n equal to 1, as n equal to 1, a1 equal to 0, this term 0. Therefore for n equal to 2 to infinity, therefore n equal to 2 to infinity f of x. Here f of x is equal to 4 by pi a0 by 2 plus n equal to 1 to infinity n, and we compute n is equal to 4 by 4 cos of n pi by 2 by pi into 1 minus n square, and an put the value and then cos of nx, and this is the Fourier series. But these two cancel, so 2 by pi plus this 4 by pi come out 4 by pi summation n equal to 2 to infinity cos of n pi by 2 cos of nx by pi into this pi here 1 minus n square. Therefore, what we have done, for a Fourier series of even function in minus pi less than x less than pi, f of x is equal to a0 by 2 plus n equal to 1 to infinity an cos of nx, where a0 2 by pi 0 to pi fx dx and an 2 by pi 0 to pi fx nx dx. Here we first complete a0. This function is even function. F of x is equal to mod of cos x. Therefore, f of x is equal to cos x for 0 to pi by 2 and minus cos x pi by 2 minus pi by 2 to pi. And here we compute a0 first, 4 by pi, and then we compute an, and this an is equal to 4 cos of n pi by 2 by pi into 1 minus n square, except for n equal to 1. n not equal to 1 এর জন্য এটা, as n equal to, for n equal to 1 this term give infinity, and Fourier series gives a finite series expansion. So for n equal to 1 compute a1, and we compute a1 here, and this a1 equal to 0. And Fourier series, for actual Fourier series is given by the function f of x is equal to a0 by 2 n equal to 1 to infinity n cos of nx. Here we put a0 to 4 by pi by 2 here, and a1 here we skip a term as a1 equal to 0. a1 cos of nx, for n equal to 1 a1 cos of x. If we put n equal to 1 here, we get a1 cos of x for n equal to 1. And this, as a1 equal to 0, this term will be 0. And for n equal to 2 to infinity, this term is an cos of nx. Therefore 2 to 4 to cancel, 2 by pi plus 4 and pi come out summation equal to 2 to infinity cos of n pi by 2 cos of nx by 1 minus n square. This is the required Fourier series expansion.